So lesson number 6 looks at the roots of quadratic equations. So we're going to look at 3 examples here. Remember, finding the roots is the same as finding the x-intercepts or finding the zeros of the equation. So if I have an equation x squared plus 7x minus 18 equals 0, to find the roots of this quadratic, I would start off by factoring. So I need to factor this quadratic. I need 2 numbers that multiply to negative 18 and add to positive 7.
Negative or positive 9 and 2. Or negative 2.
Okay? And when I write these down, I should do a double check just to make sure, yeah, x squared, yeah, negative 18, positive 9, negative 2 gives me 7. So now when I go to solve this, what values of x would make this equation true? So x equals negative 9 and x equals positive 2. So we're going to do the same thing with the second one. 6x squared minus x minus 12. This one becomes a little bit trickier because I can't solve it with the doing like in the same method that I did here with my sum and product because I have this number in front of the x squared. And for this one, if I try to do that sight method that I showed you, I'm going to have trouble because both 6 and 12 are non-prime numbers, which means I'm going to have a lot of different scenarios to think about. 6, I can have 6 times 1, 3 times 2. 12, I've got 1 times 12, 2 times 6, 3 times 4. You start putting those combinations together and it's going to be a lot of work. So in this case, I still want to put together that sum and product chart. The sum is a negative 1, but this time when I look at my product, I have to take the 2 outside numbers. It's 6 times negative 12, which equals
Negative 72.
So what are 2 numbers that multiply to negative 72 and add to negative 1? Okay, are they both positive, both negative, one of each?
9's negative, 8's positive.
So now when I go to put in my 8x and my negative 9x in this statement, in this equation, does it matter which one I put where? Does it matter where I put the 8x or where I put the negative 9x? Not really. Is there one that you want to group together more than the other? Or do you really care?
I put this 9 and 6.
Okay. So now when I get to this point with my decomposition, this is where I factor by grouping. So I look at the first 2 terms and I determine what's common to these 2 terms. Okay, so if I factor out a 3x, what will I be left with? Okay, what can I factor out of the next 2 terms? Positive or negative?
I have to be positive.
Positive. And what will that leave me with?
X minus
2x minus 3, right?
Oh, yeah.
So now I have a 2x minus 3 in common, and I'm left with a 3x plus 4. So now when I go to solve my 2x values, I can let 2x minus 3 equal 0. To get x by itself, what steps would I take?
Add 3 on both sides.
And then what?
Divide by 2.
So x would equal 3 halves. If I have 3x plus 4, to get x by itself, what would I do this time?
Subtract 4 on both sides.
And then?
Divide by 3.
So there are my 2 zeros, or my 2 roots. Okay, so let's look at the next one. 2x squared minus 8x plus 5 equals 0. So I can't do the inspection method because I have a number in front of the x squared that I can't factor out. I can't divide everything by 2. So I can't take that out, but I could possibly check about decomposition. So my sum and product chart. My sum is -8. My product, 2 times 5, is 10. So can you think of two numbers that multiply to 10 and add to 8? Add to -8. So what are the ways that I can multiply to 10? 2 and 5. And if it has to be a -8, they both have to be negative in order for this to be a positive 10 and this to be a -8. So -2 and -5 would be, okay. What else can I do? And -10 and -1 would give me, can we solve this quadratic at this point? No. So this is not possible with these methods. So how could I go about solving the zeros? How could I find the roots of this equation? What is one way that one thing that I could try doing? What are my three connections? Roots connect to what? X-intercepts. So what else could I do with this equation? I could graph it and find the x-intercepts. Do you think the x-intercepts are going to be nice numbers? Probably not. So can I find the exact value of the x-intercept using my graphing method? Probably not. There is another way that we can do this. We can complete the square. We could complete the square and then solve the completed square portion. We did that the other day. We did solve equations once we had completed the square, or when it was in that standard form. So with that ax minus p squared plus q equals 0, we moved the q over, we divided by a, we square rooted, and then we added p. So we could find the exact value of x when it's in this form. And we now know how to go from my general form to my standard form. So we're going to do that on this side of the page. So I want to isolate my x's, my 2x squared minus my 8x. The other thing that I want to do is I need to take out this a value. So I need to factor out a 2. So if I factor out a 2, what am I left with? Okay. And now I want to complete the square. So how do I complete the square of x squared minus 4x? What would I do to complete the square? Half of 4, which is? Squared is? 4. So I add a 4, and then I also subtract a 4, because what's 4 minus 4? 0. So I haven't changed the value of the equation, I've just changed the way that it looks. Plus 5. Now I can factor the quadratic. What is x squared minus 4x plus 4 equal to in factored form?
Would it be like x minus 2 squared?
Yes. The 2 would go in front of it. And what happens when I take the negative 4 out of the brackets?
X multiplied by 2.
Right. And what is negative 4 times 2? And negative 8 plus 3?
Plus
or sorry, negative 8 plus 5,
Negative 3.
negative 3. So now I have it in completed square form. I want to isolate for x, so I want to get x by itself. So my first step would be to, okay, then I would divide it by 2. Then what? Square it or square root it? Square root it. And when I go to square root the 3/2, I put a plus minus in front of it. And then my last step, how do I get rid of this minus 2? Add 2. So x would equal 2 plus or minus the square root of 3/2. So I could do this with every quadratic question that I have that I wasn't able to factor. I could complete the square and go through this process. So we're going to look at the general process. Taking the general equation, we have no numbers here, this is straight algebra. So if I follow the steps of what I did in each part. First step was to remove that 2. So the first step here would be to remove the a. So if I divide ax squared by a, I get x squared. And when I divide it by b, I will get b over a times x. Okay, I'm going to take more lines this time just because I want to go through step by step by step. The next thing that we did, which I did in the first line, was to complete the square. So how did I find out what this 4 was?
Divided the 4x by 2 squared.
Okay, so I need to take b over a and divide it by 2. What do I get when I go b over a divided by 2? So how do I divide fractions again? Invert and multiply. So then what would I get? B over 2a. And then I needed to square it. So if I square b, I get
Scream over my this one.
no. Okay. So what do I get when I square b over 2a? So square the top. What do you get when you square the top?
B squared.
And what do you get when I square 2a? 4a squared. And then I need to subtract a 4a squared. It's not pretty, but we'll keep working at it. What did I do from the first line to the second line? So what did I do in this step here?
When you factor the trinomial.
So I factored the trinomial. So if I factor this, I know that this is a perfect square because I made it a perfect square. That was adding the b squared over 4a squared and subtracting it. So I completed the squared here. So when I go to factor this, it's x plus b over 2a. And then if I multiply, so I take out the b squared over 4ac, or sorry, not 4ac, the b squared over 4a squared multiplied by a. I get a is x plus b over 2a squared. When I go to multiply this together, the a on the top is going to cancel one of these a's on the bottom. So I will get b squared minus 4a plus c. So that kind of brings us to this part right here. And from this point, what did I do with the negative 3? Moved it over to the other side. So my negative 3 is all of this. So I'm going to move all of this to the other side. I will get a positive b squared over 4a and a negative c. Then what would I do? What did I do here? Divided by 2. So I divide by an a. So I divide by an a. So if I do the same thing over here, dividing by an a, I kind of get this. I get a 1 over a. Because dividing is the same as multiplying by the reciprocal. So now I have x plus b over 2a squared. Now this part I'm going to do over here just because we are running low of space. So when I go to multiply this out, I'm going to get b squared over 4a squared minus c over a.
Do you put
But-
that, like after the equal? Is
Yeah.
that like where- okay.
But with this, when I have fractions, I want to eventually be able to put these fractions together. So in order to subtract them, what do I need? How do I subtract fractions? I need to have a common denominator. So if I look at this, and this is the, it's tricky, because my common denominator has to be, I have to have a 4 in each of them, and I'm also going to have this a squared.
Isn't it just 4a?
No, because I'm going to need this squared. And it's a squared because of right here, Jessica, when I multiply. Okay? So to go from 4a squared to 4a squared, there was no change, so my b squared will stay the way that it is. But what do I multiply a by to get to 4a squared? I multiply it by 4a, so I have to multiply the top by 4a, and I get this 4ac. So now I have b squared minus 4ac over 4a squared. That's this line right here. So what was my next step after this line?
Square root.
I took the square root. So x plus b over 2a equals the square root of b squared minus 4ac over 4a squared. Now the top here I can't square root. I'm always going to get a b squared minus 4ac. But can I square root 4? What would I get if I square rooted 4? And what would I get if I square rooted a squared? So I don't need to put the 4a squared underneath the square root because I can actually determine what the square root of that is. And then I have my plus minus. And what do I do here? What did I do? I added 2 to each side. So instead of adding, I'm going to be subtracting. But I'm going to have a negative b over 2a. Which actually works out very nice because I have a common denominator. So now I could put this all together over one line and say that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we go back to the top, it's not going to let me go back to the top. The a, the b, and the c were the coefficients of that quadratic when it was in general form. So my a is the coefficient of the first term, b was the coefficient of the x term, and c was the constant. This is the only time that you have to do this.
Okay.
This is called a proof, because what we have right here is a formula. And what did we start off with? We started off with a quadratic, hence this would be called a quadratic formula. This is the formula that you can use when you need to find the roots of a quadratic equation that you can't factor. Actually, you know what? I could use it if I needed to factor it. So that x squared minus 7x minus, or plus 7x minus 18, I could use this. It would be overkill because I should be able to factor it far quicker, but I could use the quadratic formula to find this solution for me. And if I had put in these values here, 2, -8, and 5, I get -8 plus or minus -8 squared would be 64 minus 4 times 2, which is 8, times 5 is 40, all over 2 times 2, which is 4. So I get -8 plus or minus the square root of 24 over 4. And 24 I can write as 2 root 6. Well, I could keep simplifying this. But if I put this in my calculator, if you go -8 plus root 24 all over 4, and then go 2 plus the square root of 3/2, you'll get the same answer. These are the same thing, just written in slightly different forms. And the quadratic formula you do not have to memorize. It is put on your formula sheet. It is even on the formula sheet for the diploma next year. So it is not a formula that you are expected to memorize. It is a formula that you are expected to be able to use. So the expectation is that you be able to use the formula. And having gone through physics and all of the formulas that you've used in physics, this shouldn't be a difficult process to put stuff in. You're never going to have to solve for, you're never going to have to rearrange this formula and solve for A, given the X. You're just going to have to put the formula in this way, because there's other ways that we could solve for A, B, or C in those cases. So find the roots of the following equation using the quadratic formula as exact values in simplest form, which means we would simplify any radicals that we have, and to the nearest tenth. So if I look at this first one, A, what's the coefficient on x squared?
1.
So A would be equal to 1. B would be equal to, and C would be equal to. So my negative b would become -2 plus or minus the square root of b squared, so 2 squared, which is 4, minus 4 times a times c. That should be 4 squared. Take this and we'll go one step at a time. So 2 squared minus 4 times 1 times -1, all over 2 times a. So now I have a negative 2 plus or minus the square root of 2 squared is 4. And think of this as being a negative 4 times 1 times negative 1 would equal positive 4. So always think of this as a negative 4 and then multiply it by the next two terms, and then you don't have to worry about if it's minus a negative or minus a positive. The two negatives cancel each other out. If there's not two negatives, it stays as a minus. Okay, 4 plus 4. Can I simplify the radical of 8? 4 and 2. So the square root of 4 is 2. So 8 would become 2 root 2. If I have a 2 on the outside of all three terms, I can divide all three terms by 2. So negative 2 divided by 2 equals 2 divided by 2 equals, so I'd have just the square root of 2. And then on the bottom I have 2 divided by 2, which is 1, and do I need to put it there? No. So x would equal negative 1 plus root 2 and negative 1 minus root 2. So that's in simplest form. If I grab my calculator and now put this into the calculator, I have negative 1 plus root 2. There we go. 0.4. And then if I wanted to do minus, remember I think I showed you on Friday, I can go second, enter, and it retypes it, and then I can scroll back to the plus, change it to minus, and I get negative 2.4. So to the nearest tenth, my answers would be 0.4 and negative 2.4. Okay? I want you to try B on your own. So if we look at part B, x would equal, so A is equal to 4, B is negative 12, and C is 3. So when I go to put in my negative B, this time it's negative of negative 12. So I'd have the two negatives, which means eventually I'm going to get a positive 12. Plus or minus the square root of b squared minus 4 times a times c. So all over 2 times a. So negative of my negative 12 becomes a positive 12, plus or minus 12 squared, which is 144, and 4 times 4 times 3 is 48. All over 8. So 144 minus 48 is 96. Over 8. And 96, I think, it's 16 times 6. So then I get 12 plus or minus 4 root 6 all over 8. I can divide the 12, the 4, and the 8 all by 4. And I get 3 plus or minus root 6 over 2. Which, when I put in the calculator, I get 0.3 and and 2.7. How would I start off C? What would I do to begin with?
Rearrange it so it equals 0.
Rearrange it so it equals 0. Remove the brackets. So if I remove the brackets, I get 12x plus 15. And then I move everything to one side. So I get a negative 12x and a negative 15 equals 0. And then I use the quadratic formula. So again, take some time to work through that, please. Okay, so let's start. Negative b would be negative of negative 12, so I would get a positive 12. Plus or minus the square root of b squared, which is going to be 144, minus 4ac. So 4 times negative 15. So 4 times negative 15 is negative 60. Negative 60 times negative 4 gives me a positive 240, all over 2a, which is 8. So I've skipped I've skipped the substitution part just because I don't have room. 12 plus or minus the square root of 384 all over 8. And with a number like 384, I should be looking at whether or not I can take out a perfect square. So can I divide it by 4? Yes. But because 384 is such a big number, I'm going to go higher than 4. Can I divide it by 16? The answer is yes again. But I still am left with a pretty big number when I divide it by 16. See, if I grab my calculator, 384 divided by 16, I get 24, and I know I can divide 24 by 4. So if I can go to 16, the next one up from 16 that fits that pattern is 64. So 384 divided by 64 gives me 6. And I can't pull out a square root or a perfect square factor out of 6. So that tells me that 64 is the biggest perfect square that I can pull out of there. So 64 times 6. So this would give me 12 plus or minus the square root of 64, which is 8, root 6, over 8. 12, 8, and 8 can all be divided by 4. So I would get 3 plus or minus 2 root 6 over 2, which gives me for my answers negative 0.9 and 3.9. So if we look at class example number 3, the last one, find the zeros of the quadratic function. Zeros are the same as roots of the equation. So the zeros of the function are the same as the roots of the equation, which means I can let f of x equal 0. And then I can solve for x. In this case, if I moved everything to the other side of the equation, it would still equal the same thing. My signs would all become the opposite. The only reason I might want to do this is I might want to do this to see if I could actually factor this. Could I find two numbers that have a sum of negative 4 and a product of negative 3? So in order to get negative 3, the only way I can do that is with a 3 and a 1. And in order to make it a negative 3, one of them has to be positive, one has to be negative. So if I make the 3 negative, I get negative 2. If I made the 1 negative, I get a positive 2. So I can't factor this. We always want to check whether or not we can factor the quadratic, because factoring is a simpler process. Then if we can't factor, then we use the quadratic formula. So the quadratic formula, negative of negative b. So it doesn't matter which equation you use. Either one of them will work. So because we've written the second one out, we'll use the second one. Negative of negative b would be a positive 4 plus or minus b squared, which would be 16 minus, I'm putting 16 squared. 16 minus 4ac, so 4 times a is 12 times 1 is negative 12, so minus a negative 12 would be plus 12, all over 2 times a, which is 6, and 16 and 12 is 28. Can I divide 28 by a perfect square factor? 7 and 4. So 4 becomes my perfect square. So I would get 4 plus or minus 2 root 7 all over 6. Divide everything by 2. And I would get 2 plus or minus root 7 over 3. And when you put that into the calculator, what do you get to the nearest hundredth this time? What'd you get?
1.55 and negative 0.22.
22? Good. Okay, so your practice questions. Question 4B. Uh, 5 A and B. 6B, and then 7, 8, and 9.